This is a next-gen web track. The talk is called Reverse Engineering Browser Components, Dissecting and Hacking Silverlight, HTML5, and Flex. Please give a warm welcome to Sriraj Shah.
Thank you. Okay, so before I start, just a brief introduction. I'm a founder and director of a company called Blue Solutions, and we primarily focus on application security. In past work with NetSquare, Foundstone, Chase, and IBM. My primary interest is doing research on application security, and last couple of years focusing on more on Web 2.0, Silverlight, Flash, SOA, etc. A lot of papers and tools written by me. You can find it on the site. And these are some of the books written by me. Web 2.0 security, hacking web services, and web hacking. Okay, so let's get going. So the plan for next 1 hour would be, I will start with some basic bird eye view of application security landscape. Then we'll focus on techniques for reverse engineering browser components. So we'll try to address source, object, and runtime analysis. We'll focus on analyzing AJAX-driven HTML5 and DOM-based applications. We'll touch upon Silverlight and a Flash-based application, something on a mobile devices as such. Try to see some application defense. We'll cover some of the demos as we go. I'm planning to have some of the new tools getting up, XAP scan, AppCode trace, ScanDroid, and HTML5 scanning. Try to discuss some tricks for scanning, flash checking, eval, the eval, etc. So that's the plan for the talk. Bird eye view, essentially we do around 10 to 15 applications per week where we do manual testing and scanning as such. And lately what we are seeing is when you're doing just scanning, some of the things which are getting missed is DOM-based XSS, hidden business logic, information leakage. A lot of components which are running on RIA using Flash and a Silverlight is difficult to assess and audit. We miss BSQL, that's a blind SQL, over various different streams, be it a JSON or XML and so on. So these is a big chunk of vulnerability which are getting missed while you are doing automated scanning, not paying a lot of attention with the human skills as such. And if you try to analyze why we are missing this and try to identify what is a problem domain, one is scanners are failing in discovery. So say it's possible that you have your SOA residing in your Flash, or say you have a business logic which is running on the Silverlight and so on. Architectures are complex. We have various different set of JavaScripts coming in and so on. A lot of libraries out there. So it's making things difficult. At the same time, nowadays you have a lot of code which is coming on a client side, so we need some kind of a white box analysis needs to be done on the client side components and difficult to discover as such. So while doing manual assessment and audit, we come up with various different approaches, and one of them is essentially doing a black box testing where you add some components of white box analysis like a source and object level analysis on the client side. And deep protocol inspection for over what kind of a traffic which is going on HTTP as such. So this helps in identifying the vulnerabilities which we usually miss by automated scanner as such. So one of the major technology shift which you can see in the past when we are looking at Web 1.0 application, we had complete layers where we say, okay, this is my data access layer, runs on server, this is my business logic layer, runs on server, and this is my presentation layer which runs using HTML and JavaScript which runs in my browser. Now that particular layer is essentially what have happened with the introduction of these new set of technologies. It's pretty much not just residing on a server. There are certain components which are actually coming out and running on the browser. So what we have is this little gray area, which you are green area, which you are looking at, is a part of a presentation layer, business logic layer, as well as some kind of a data access layer. Is not running on your server, but it is running from your browser. And that component has introduction of various new set of technologies like HTML5, storage, WebSocket, WebSQL, and XHR. All these are actually running from your browser. If you look at Silverlight, that's the Microsoft platform, WCF, .NET, Silverlight. Again, this is running from your browser. And on a Flash or Adobe, you have a Flash, AMF, FLAC, storage, XAML, and so on. And then everything get glued by your document object model and JS. And on top of it, you have a stack which runs on a mobile devices, be it Android, iPhone, iPad, and so on. And these mobile applications call the browser component inside their application and maybe making a HTML5 call or using the storage or a file system and so on. So this is one of the major shift which we are looking at. So we take a Flash application, decompile, and try to see whether do we have any browser server-side components which are running on a server, say maybe a data access call or maybe business logic and so on. So this is one of the area where lot of different technology evolution has happened in last 1.5 or 2 or 3 years, which we are seeing in real life application in current context. So what are the new features inside browser? Support for various other technologies and plugins, Silverlight and Flash, QuickTime, etc. We have a new set of tags which are coming in, which is media, forms, iframe, etc. Again, HTML5 has opened up a new stack of tags here. We have XML HTTP request object, which is level 2. So we had a level 1. Now we are on a level 2, which allows some kind of a shared resource access over cross domain. We have a WebSocket, so again a TCP streaming over a WebSocket available directly from the browser. Interestingly, now we have lots of different storage capabilities in the browser. We can store session, local, or global. So we have a local storage APIs inside the browser as a part of HTML5, which runs. We have a WebSQL database, which again is run on the browser. So you can have your own little database which runs inside a browser. So when you load the page, you can say, okay, dump this data or data contacts into my browser, and the browser will not come and make a query on the back end. It will just make a query on the local browser itself. We have very powerful document object model, which is DOM level 3 specs. Sandboxing and iframe isolations, logic are in place in various different browsers, be it a Chrome or a Firefox and so on. And browsers or libraries are supporting all sorts of streams now, like JSON, AMF, WCF, XML, and so on. And all these are also can be accessed over a mobile. So this is how the whole landscape of, say, browsers are evolving. So what is a browser model? If you look at, definitely there is a core policies on the bottom, which talks about same origin policy and sandboxing. Then on the top we have a network access layer where we have essentially 3 to 4 ways of talking to the server or across domain calls as well. XHR, WebSocket, plugin sockets. We have a browser native network services and so on. And then the top 2 levels are interested for us. One is a process logic, where you have definitely a JavaScript running. Then you have the whole DOM and event model, which allows you to access WebSQL and a storage which is residing in your browser. And then you have a parsers and threads. So now you have in your browser you have something called web workers. So you can start a process inside your web page itself. So you can have a web workers running for you inside your HTML page. And topping up the presentation layer, there are 3 important stacks. One is HTML5, a Silverlight, and a Flash. And HTML5 is native to the browser, while Silverlight and a Flash needs a plugin beneath to run it. And pretty much all these technologies are supported across browsers. HTML5, some browsers support some set of technologies, others are not supporting it. I think Chrome 5 is supporting HTML5 fully, and then IE and Firefox supporting in their limited capabilities. So these are the layers: presentation, process logic, network access, and a core policies, where SOP, sandbox, and a shared resources. These are the 3 important policies. So application architecture, if you look at, for 2.0 or next generation applications are changing. So what we have over here is a browser which is running Ajax, Flash, HTML, JS will make a call to your web server will make call to your application server. And then what you have is thin layers like web services, data access, and authentication, which will fetch the information locally from the server. And then the whole web services will go out and try to communicate with various different boxes out there, maybe your banking application, trading application, weather, email, blog, etc., and then tunnel all the data from third party back to your browser. So this tunnel is essentially maybe supplying data in a JSON or XML or AMF or so on. So whatever way new data is coming, you are tunneling it back to your browser, and that browser can be running on your mobile device or browser can be running on your laptop and so on. So this is kind of a application architecture we are looking at in current context, where your information source is not just local to the box or local to your application. The source is actually the whole internet. You are maybe fetching information from anywhere and tunneling that information back to the browser. So one of the weakest link in this architecture is this trust of the information, because now you are fetching information which is completely untrusted sources. So you have a malicious JavaScript coming, or you have some untrusted data coming and going back to your browser. This essentially expands the attack surface. So on a server side, we have a query string, post name, XML, JSON, HTTP variable, file attachment, feeds, open APIs, etc. would be your web server side components. And then on the browser side, you have entry points like JSON, HTTP response, DOM calls, events, API streams, and so on. So this is how this whole new architecture would expand attack surface, will give you more entry points to both the server and the browser end. If you look at the AppSec dynamics, which keep on changing over years, if 4 to 7 and 7 to 10, if you look at the OS top 10, there are a few changes here and there. For example, in last we had a unvalidated redirects and forward added. Now we have a security misconfiguration added over here, but still A1 and A2 would be injection and cross-site scripting, and then there are a bunch of other attack vectors. Now if we try to map it to this new generation or a new stack of browser technologies which we have and try to map it, so on the injection, we have a JSON, AMF, and so on the server side, and web SQL injection on the client side. A2, that's cross-site scripting, DOM-based script injections, direct third-party streams, HTML tags. There are a bunch of new HTML5 tags out there which can cause cross-site scripting. A broken authentication is interesting, where partial logic would be residing on your browser. So pretty much one can bypass that, be it a local storage or be it a JS, Flash, or Silverlight. So there are persistent cookies which are kicking in your HTML5 and a local storage. Insecure direct object referencing, again, it's pointing to a database layer, maybe directly accessing through a browser. CSRF with XML, JSON, AMF string, XHR, server security misconfiguration, trust model, as I discussed. Hidden URL and so on. A8, where you have unvalidated redirects, where again you have a DOM-based redirect and spoofing is possible. So this is how, and then you have a whole stack of mobile 10, which again you can link it to some of these browser components. Okay, so this is basic. Now we'll move into reverse engineering. So if you look at the stack, the kind of a stack which we are looking in the browser, HTML5, Silverlight, Flash, and Flax over SWF. And then browser will be making all sorts of different calls. These calls would be asynchronous call or a synchronous call going to the server. The streams would be XML, JSON, and so on. And your Flash or a Flax may be making a backend call over SOAP or AMF and so on. So let me quickly show this little demo here. So here is an application where you have all different flavors of protocols and stuff like XML, Flash, JSON, Silverlight, AMF, HTML5 over here. And if you open up the Chrome toolbox. They have a development toolbox tools out there which will show you some of these HTML5 stuff over here. It will say if it has a database, it has a local storage, if it has a say session storage or so on, and then network will show you all the protocol as such. So quickly analyzing the protocols and inner mechanism, you can use this plugin. So it will show you the calls which are going back and forth over here. So this first call, say for example ASPX, which is making a call to the back end, and it is going over, so if I click any of these links over here, and it will actually make a call at the back end, and this essentially XML call which is going at the back end. Or for example, if we take over here, we'll go to the JSON call and try to see. Okay, so now this particular call, which is of the JSON string, so it will make a backend call to JSON service ASHX, is a JSON call. Now we click on the AMF traffic. So we have the plugin which gets called, and the whole application gets loaded in a flash. So it will make a call at the back end to gateway ASPX, which is essentially a binary protocol which is going here, which is AMF traffic. So AMF traffic going from a Flax driven or a Flash driven application over here. It will take across. Now this is a Silverlight. So now we are loading a Silverlight application. We'll look for a client access policy and so on, and making a backend call to DVDs for less.asmx, which is a SOA based resource as such. Now we are loading the HTML5 application over here. So if you look at the HTML5 application and try to see resource, you can see a category where a database has been created on the browser. So if you click over here, and you can see the database over here. This is essentially a local database, which is a web SQL over here, and so on. So this is how the current application would be running in a browser. It has multiple protocols, it has a multiple stack to address, be it a Silverlight, a Flash, Flax, and so on. Okay, so reverse engineering approach. There are a few different approaches which you can take while doing a reverse engineering. One is a static code analysis, object code observation, runtime instrumentation, and scope reduction and protocol analysis as such. And objective is to find and track vulnerabilities or any weaknesses which we have on the application. So we are defining our scope here. We are not looking at the browser components which are written by the vendors. We are focusing on the application level components which are designed, developed, and integrated by developers. And these components would be mainly sitting in this two area, presentation and process logic area, and making a call to web SQL and a storage. And these components may be written by HTML in HTML5 or Silverlight or Adobe and so on. So that's our scope of analysis. Goals is essentially what we are looking at is doing the assessment and putting up countermeasures during your secure SDLC. So discovering a hidden resource, call identification and manipulations, understanding inner calls, browser events and script mapping, variable or call traversal, and so on. So these are the essential goals to discover vulnerabilities over here. So starting with AJAX, DOM, and HTML5 based applications. So we can have three approaches over here while doing a reverse engineering. One is doing a static code analysis, or you can do a runtime analysis, or you can do a debugging and discovery. So first is essentially what we are doing is a static code analysis where we load the page in the browser and then try to perform a static code analysis over a JavaScript. So say for example, over here we have a tool called DOM scan. So DOM scan will actually load you open a DOM scan and say, okay, this is the URL which I want to analyze. So it will go and load all the calls over here. So what have happened is it will start the IE instance of IE. It will start. Okay, just hold on. So it will start an instance of IE, load the page, load all the JavaScript, and everything would be available on the DOM scan console over here. So now I have all the components which are running in my browser are loaded on DOM scan, and I say, okay, show me all my eval, hidden, and document.write call. so I can perform some kind of a static code analysis over here. So it will start scanning application, it will start scanning the pages over here, and will show where the calls are. So we found these many eval calls over here, and then we have this particular eval call, and now we are interested in doing the tainted flow analysis. So we try to say, okay, traverse across the variable where this particular variable is going, coming from and going through. So we'll try to analyze a source and a sink for it. So it's okay, going into this particular function, and then it's going to this function, and so on. So it's traverse across application and show the path of its traversal over here. And then finally, it hits to your location. So it's going to your search location bar. So now we know that the variable is actually coming from here and hitting to your eval call. So this particular routine, now you can have a clear case of cross-site scripting. So I can actually inject anything over here. This particular variable, which is PID equal to 2, and this is again a DOM based cross-site scripting, which is directly going and injected into our eval routine. So now over here, if I say instead of a 2, I close the loop and say comment the rest of the script here, and then pretty much this is a raw JavaScript or a raw script handle which we have, so we can start injecting anything over here. We say, okay, alert or whatever we want to do over here, document.cookie and so on. So this is the way how the first approach is doing a static code analysis by which we can actually find or discover a vulnerability. The second one is even more interesting, where we do a runtime analysis, because say for example, you load an application and click a button. When you click a button, when you load an application, you may get 50,000 lines of JavaScript coming in loaded in your browser. But when you click a button, out of this 50,000 script, only 50 lines of JavaScript is going to get executed, which is mapped to that particular event or a function. So what we have created is a little plugin for Firefox, which is called a DOM tracer. So you can start a DOM tracer, and what we have added is some of the rules as well. So you can say, okay, what you're looking for while the call is going through. So you can define those parameters in your rules file. So okay, you say, I want to analyze this particular application, and what I want to do is show me when a browser makes eval call or document.write calls or inner HTML. You can put all the calls which you are interested in tracking. So you have all these different calls defined in your rules file. There's a simple regular expression which you are putting in, and then just passing the file over here, and now you're starting your tracer. So now this particular window, whenever you fire an event, whatever functions are getting called or whatever lines of JavaScript being executed will show you, and then you can take your analysis from that point onwards. So we click this particular link here. So bunch of JavaScript which is executed, and you can see over here the profile of the call. So it will show, okay, I executed this function first, which is line number 92 over here. So this function was executed, and you can see little 3 arrows over here, which shows whatever you have mapped to your rules file. Let's say, okay, this particular guy is using an eval call here. And these are your document.getElement calls and so on. So this is where we are doing a scope reduction. We say, okay, after 100,000 of lines of code, now we have our scope reduction to 100 lines or 150 lines only. So this is a kind of doing a runtime analysis. And a third approach which you can take is a debugging. There are good debuggers out there for a JavaScript, and my favorite one is a Firebug. Firebug has a debugger bundled in. So say for example over here, this particular application where it's a completely 2.0 application where a business logic is residing over here. So you click bank information over here. So say for example, I logged into the application, and this particular application showing you, okay, these are my banking information, which say, okay, my bank account with Access, and this is my number over here. And when I make this particular call, you can see over here encoded value which is going in. So they have the whole application is written in JavaScript, and it has some business logic embedded in the JavaScript, which is allowing these kind of encryption, this kind of calls which are get made at the back end using AJAX or so on. Okay, so now over here, we go ahead and open a Firebug console. So this is essentially a Firebug console which you are looking at over here, and we'll show you all the JavaScript over here. And you can say, okay, show me getBank function, because that's the function which I was interested in. So it is showing me a getBank function, and you can see over here some keys are created and some encryption is going on and so on. So there is a bunch of things which may be going in while you make this particular call. So I'm interested in tracking this call, so I set up a debug point over here and say click the function again. So now my execution has been stopped here, and now I can play around with the variables inside the browser memory and try to see what can I extract from the functions. So over here, for example, the key is this and the plane is Shrirat. So I change it to say some other user, say Nisha is another user, and I say okay, play. Now you can see the whole banking information has been changed. Now I'm not looking at my banking information, but the other user's banking information, since the business logic, a partial business logic, has been transferred from server to the browser. So again, this is a third different way how you can go ahead and try to analyze a JavaScript. So you can use a static code analysis, you can do a runtime, scope reduction, and third is a debugging. Yeah.
Dynamic analysis, actually you can even measure the corrupt tool, but actually do taint analysis on code.
Which analysis?
Taint analysis.
Okay, taint analysis on the code.
There's no need to scope down, it's just you do, there's a tool, for example, now it's been released called Dominator.
Okay.
Actually, it's integrated into Firefox.
Okay.
The JavaScript code
Mm-hmm.
that run.
Mm-hmm.
Then the variable that are taken in input during a get or a post,
Right.
they are tainted.
Yeah. So what he's saying is, like, there is a possibility if you have the whole tainted analysis, the first one, SCA analysis, where you can completely automate if you have a tool like Dominator, which will allow you to do the complete analysis in automated fashion. So you may not have to do a scope reduction as well. Yeah, true. That's possible. You can have if you have a full-fledged static code analysis which runs and parse the JavaScript, then pretty much you can do that on the fly. The second application is like looking at the Flash and a Flax apps. So what we have is Flash is a very simple framework which is nowadays running on a Flax framework. So there are a set of technologies involved in a Flax. One is like MXML, ActionScript, and a JavaScript. So it allows you to write your application in those languages. So it's pretty simple. You can create your XML document, which is your presentation layer, which gets converted into a SWF or a Flash file. And whatever you want to have a dynamic code will get converted into ActionScript. So you can write those stuff in an ActionScript and then just use compilers like MLC compiler or so on. And you can pick a switch if you want to create a web-based application or you want to create a offline Adobe Air application. So based on that, you do a coding once, but you get two flavors of application at the same time. So you get a desktop application or you get a web-based application. Again, the application which gets created is a format is called SWF. So it will get the SWF format application over here. So your application will be in SWF format. You can decompile these SWF format files and try to analyze what is residing. SWF files talks with the backend on AMF protocol. So it runs on action message formatting protocol, and then you can have various different sorts of vulnerabilities in your Flash files as well, be it a cross-site scripting or server-side injections and so on. So say for example over here, you have a simple file, simple SWF file over here. So first, one thing which you can always do is download the SWF file and decompile the file. So you can do a view source and we can identify SWF files over here. And there are tools out there, where various different decompilers out there. One of them is called SWF dump. So you can use SWF dump, say this is the inventory SWF file which I want to dump. So I get the actual bytecode of the SWF file, and then I start discovering the components inside SWF file. I say, okay, show me the backend web services. So it will say show me the backend services or a gateway calls and so on. So I can identify these calls over here, or a product method at the backend and so on. So a lot of different things which you can harvest from this calls. You can find public properties, you can find publicly called function and so on. So all this pretty much you can identify, and then you can reverse match with the actual HTTP traffic over here. So one thing you can do that, and then definitely if you find the AMF streams, which you can find from Flash making a call to AMF, these AMF streams can be injected as such. So this where we are passing admin, for example, in a function here. And we can use a proxy which do a AMF decoding and encoding. So say for example burp is doing it, or a Charles proxy and so on. So you can identify if this is an example of a Charles proxy. So over here you have this particular AMF traffic which is going to the server. We copy it, make another instance of the call, and now we go ahead and into AMF and say okay, change admin to single quote, for example, and try to execute over here. And you can see the whole stack which is coming back. So there is an possible SQL injection over here. So next you can actually go ahead and edit it and try to pass on the payload, say 1 or 1 equal to 1 and so on. So this is again I would say a deep packet injection or deep analysis of a protocol which needs, and same with the WCF protocol, which is a Windows protocol as such. Similarly, you can, from the call, you can grab certain patterns, and based on that you can find some of the vulnerabilities. For example, over here we say okay, this is another file, SWF file, and it is using, say for example, get URL call. So this can be vulnerable to a scripting, or this particular application is actually taking variable and rendering into HTML inside your Flash file. As you can see over here, HTML rendering is happening. So it's possible to have a cross-site scripting over here. So if you look at the actual application over here of SWF file, okay. So this is your test3.swf file, and this is your another SWF file which we are looking at. So now if we, instead of this, we submit it, and the parameters are actually going from over here. So instead of that, since it is doing HTML rendering, we can pass on ahref over here, and it will actually cause a cross-site scripting. And similarly, if it is taking a get URL call inside your Flash file, then also it's possible to cause a cross-site scripting. So this is essentially how you can do a decompilation of SWF file and try to identify various different issues associated with your application as such. So this is where we are passing the click tag here. And instead of the URL, we are passing a JavaScript alert, which is going to get executed on the browser. Okay, so this is how Flash files or a Flash application can be analyzed and decompiled. Another interesting application issue which we are seeing is something called flash jacking. So what we have over here is a combination of a DOM-based cross-site scripting, CSRF, and a Flash. So say for example, you have your banking application where a Flash plugin or a Flash application is your login. So you have a login.swf file, for example, and on the same page you have a DOM-based cross-site scripting, for example. So it's possible actually to make these kind of a call where say document.get element and fetch the actual location of SWF file and then point it to some malicious SWF file which gets loaded instead of your actual SWF file over here. So this is exactly like we used to do a click jacking. This is kind of a flash jacking where we hijack the actual flash application to something else in your browser. So say for example, over here you say for example this is your actual bank. So this is a banking application, and if you look at it's running on 100.111. It can be completely a different domain as such. And you have this login.swf file over here. And somewhere over here you have an eval login. So it is actually a DOM based eval call which is going inside the browser. So now say for example we go to the something different. It's an alert one, so it's actually just running the cross-site scripting. So that's a vulnerability over here. Now instead of alert, we try to do alert high, for example, over here. And as you can see over here, since browser is going to do URL encoding, it's going to pass on %20 to %22. And this is going to not going to get executed because eval call will not entertain %22 as such. So that's another problem which we need to bypass if you want to exploit this particular scenario as such. Now you have the another page over here, which is in completely separate domain. It's running on a 100.200 can be another domain as such. And as you can see, the pages is the same. There is just the one line. The SWF file is the same. Just for the verification, I've just kept a little red line over here. So this has been kept here. Now I go back to the target domain over here, and I say I just want to inject something over here. So this is my kind of a payload, document.get element by name login item equal to 0 and src. So get the source of that login.swf file and replace it to my malicious SWF file which is running on 200.80.80. So I can actually grab this information over here. Okay. So I take this guy and inside your, just to show over here, my DOM variable, if I do a simple document.call for a login, I can see this particular URL. And now I want to change it to, instead of 100, I want to change it to 200. So now I can actually go ahead and pass on this information over here. But what is going to happen if I inject this thing raw in a raw fashion, it's not going to work because it has a single quote and a double quote, which is going to get converted and that into the eval call. When it goes into eval call, it's not going to get executed. So the JavaScript is going to give me error. So what we can do over here is we convert this whole payload into a string from char code. So it will actually go into a simple character and we do a first eval. So we already have one eval in the browser and we add up the another eval from our side. So the first eval will actually convert this into this, and the second eval inside the browser will actually execute. So it is a kind of a trick where we are doing a double eval. So this is a pretty, when you are doing eval and if you eval the get parameters are going, a call from a get is going into eval, then you need to do something like this. So we are doing a double eval over here and take this as our payload. And pass it over here. And as you can see, the 200 red lined flash file is actually loaded on our domain. So this is where we bypassed the cross domain, we bypassed the CSRF. It's a combination of a DOM based XSS along with the CSRF and so on, because embed an object tag of a flash or a Silverlight will allow you to do SOP bypasses as such. So this is kind of a flash checking. It's possible to do a flash checking. It is possible to do a reverse flash checking as well. And this is a trick where we are doing a double eval. So we are doing the eval. It's like a double decode. It's like a double eval which we are doing over here. Same with the Silverlight. So flash application, after compilation, flash application create SWF file. Over here, if you are using a Silverlight application, then Silverlight is actually, the application runs in a .NET framework. So you can write your code in a C# or a VB.NET and compile the code, and it will create a DLL or a package which is get loaded in your browser as such. So it has a similarly like a Flax, it has its own markup language which you can mark up the XML data, and then you can compile the application, and the application will actually create something called XAP file. XAP file is nothing but the compressed file, so it's like a zip file. And XAP file would have all the information needed to execute your application. So it will have a config file, it will have a DLLs, it will contain your cross-domain policies, client access policies, and so on. So everything would be part of your XAP file. So what we want to do is we want to analyze XAP files as such over here. So we created a utility called XAP scan, which allows you to do scanning on your XAP files or a ZAP file. So over here you have this particular page, and if you browse down the page, there is a test.xap file over here, which runs the Silverlight, which runs in this particular plugin runs in the Silverlight. So we take this particular URL and we start XAP scan here. So this is a typical GUI of XAP scan. Pass on the URL over here and start scan. So it'll go and grab it'll go grab XAP file, decompress the file, and find important files as such. So it is getting the package, it is extracting the package as such, and trying to find isolated storage, like a local storage if the application is using. So this is your HTML package, this is your XAP package or a calls. Over here you can see the config file will show you the backend calls or a backend resource. So this particular Silverlight application is actually making a backend call to backend service-oriented architecture files called dvds4less.asmx file. So we'll find that. Isolated storage is essentially a local storage if your application or Silverlight application is doing a storage on your box. So persistent cookies kind of stuff. And then you have assembly over here, which is extracted from ILDSM. So you can identify whatever calls or something which you are interested in finding, you can find over here, or a trace of variable and so on. And these are your policy, cross-domain policy and a client access policy. So you can see whether this particular application allows you to make a cross-domain calls or client access policy and so on. So this is how you can leverage the tool to identify XAP related, Silverlight related issues or application. Once you find the backend call, say for example over here we found that dvds4less.asmx file. So there is a SOAP file at the backend. So this is your WSDL file. You can take this WSDL file and pretty much use another tool called WS Scanner. You can find that particular tool on our site as well. So this particular tool will actually go ahead and grab your WSDL file. It will convert, it will find the functions, and then it allows you to make a actual call. So you say, okay, this is my get product ID call which I want to make. So you have ID equal to 1 here, and you actually get the information back. So Silverlight is a front end, and it is at the back end, it is making the call over a SOAP. And then you can actually start fuzzing this particular variable like a regular post or a get variable. So we can start, say for example, instead of a 1, what if I put a $, and what if I put single quote and so on. And it has a built-in fuzzer as such, so you can use that if needed. So it will say, okay, this is SQL client, some error pointing to a possible potential SQL injection over here. So this is an interesting analysis which you can do. We just created another tool called AppCode Trace. So this AppCode Trace is essentially a tool which allows you to do a runtime analysis on your binary, both native DLLs or a Silverlight driven DLLs as such. So over here, what we are doing is there is a Silverlight application over here. So we do a view source here, where we found this test.xap file over here. So our objective over here is to take the DLL file, patch DLL file, and then load the DLL, then load the XAP file. So whatever our XAP application is doing, we can monitor all these different calls which are going through the DLL. So that's what our objective is. So that's what we are planning over here. So we get test XAP locally on our system. We change the extension to zip and uncompress the file. We start a command prompt here and go to the program files, AppCode Trace. So over here now what we are saying is, okay, my input is my test.dll file and it's a Silverlight. So it will start patching the DLL. It will patch the DLL, and now we have a new DLL with us. So now we take all the files back, create an archive again, change it to say XAP, and put it back locally. And we create a small HTML page which calls this test.xap file. So now we have the file loaded locally. We start a debug view over here, run as administrator. And now whatever call we make, we can actually watch the DLL, what kind of a calls which DLL file is making as such. So this is the calls which DLL file is making. So from which we can identify whether it is using isolated storage, or whether this particular call is using SOAP, whether this particular call is using any APIs which it's not supposed to use. So this is how you can do a runtime analysis for Silverlight or a .NET using the patching. So we go ahead and patch actual binary and then try to call the binary, and the binary will actually show us all different calls. You can use this particular AppCode Trace for your server-side application as well. So say for example you have a DLLs and a server-side application is using DLL, you patch the DLLs and then call the DLLs, and the DLL dump will be created at runtime. So this again will help you in reducing the scope and identifying the calls. And similarly, like we have looked at a flash jacking, there is possibility of a XAP jacking or a Silverlight jacking, where again a combination of a DOM-based XSS, CSRF, and a Silverlight. As we change document.get element to SWF file, we can change similarly to login.xap file as well. So what we are doing is just underlying component of a flash or SWF or XAP, which we are changing dynamically. So both of these technologies actually get into the browser by either object tag or embed tag, and both of these tags are essentially allows you to make a cross-domain calls, like an image tag, where you can actually, you are on a google.com, but you can fetch image from a cnn.com. Similarly, these two object and an embed tag will allow you to do so. So that gives you a rise to a variant of click jacking. Now we are looking at the click jacking extended to RIA space, be it a Silverlight or a Flash. Similar application we are looking at is analyzing mobile applications. Say for example, mobile application written in Android or iPhone is again inside your application. You will look at the application and you will see, okay, this is a simple application, but inside the application a small instance of a browser is created, and then browser is actually making a part of the calls. So we want to identify whether this particular application is using any browser driven components or calls or not. So you have, say for example, if you're using Android application is creating into APK file, and APK is actually where you have a DEX DEX components would be residing, and you can actually convert them back into a Java code, and then you can run your static analysis on top of it. So what you have over here is a scandroid.ruby component which we have on our site, which you can use to scan. So for example, over here it's a very simple buy me application which runs on Android. So it looks very simple application which has been created. You buy and then you can see stuff over here. Now if you want to analyze this particular application, then say for example we run a scandroid and we say, okay, APK file, this is my buy.apk file, and I pass on the rule which is residing on a rules.cfg file, for example, over here, and I run this particular. So this tool is essentially going to convert everything to the backward. So it will convert APK to back to DEX and DEX back to your Java, and then we'll run some rules on top of it. So it will process everything, and at the end it will create two files, which is output.txt and a permissions.txt files. So you open output.txt file over here, and you can see web view. So web views are essentially the browser driven components which are running inside your Android application. You can see over here, for example, backend URLs as such, credit.php, these are a web view, get setting, and so on. It loads URL and so on. So this is a one analysis which we do a reverse tracking and try to identify what kind of application created inside your APK file. And you can see the permissions.txt file as such, which allows that, okay, this particular application allows you to make a internet calls or a network socket calls on top of it. So this is how quickly you can do a mobile application review written in iPhone or Android and so on. And again, what we are looking at is what kind of client-side components this guy is using. So all these different techniques which we have seen, we can apply to various different browser components. For example, if we start with HTML5, there are various different set of different new tags which are added in HTML5. Say for example, a media tag which allows you to load a video and audio, where on error or on poster you can actually implement JavaScript alert. Form tag has some new components added, say for example on input new attribute which takes a JavaScript. So there are various different interesting tags which are added in your in HTML5. So we just created a small utility called HTML5 scanner. So over here you can pass on the URLs by one URL or the file, and these are essentially a bunch of tags over here. You can see over here art and section and video and so on. So you just want to see whether this particular application is using HTML5, and if it is using HTML5 to what extent. And last two is very important. One is a local storage and the local data. So web SQL and a local storage. So we say, okay, take few URLs and scan for us. So take HTML5 and start over here. So you can see this particular application is using this many tags. So we do a fingerprinting or HTML5 fingerprinting and try to identify whether some important tags are there or not. And if it finds, say, for example, section tag or so on, which is clearly HTML5 stuff, we'll come out and point it to. And over here, for example, you have a local data, so it will show us local data usage over here. So these are the local storage lines. Local data or a local database has been used. So this is how you can play around with your HTML5 applications or HTML5 related stuff. So when we are focusing on HTML5, one of the area which is part of HTML5 is your storage. So it has a new feature of interface for a storage which allows you to do a local storage on your browser. So for example, there is a get item and a set item to your storage. So you can say local storage dot set item this hash. It is more or less like your cookie, which gets stored inside your browser, which is at the transport layer. This is at the DOM level as such. So you have that particular piece of information residing over here. One of the interesting thing in a local storage is that say for example you have this local storage created on a login page. So when you logged in, information gets stored in your local storage. Now this information is available across the domain. So say for example you have cross-site scripting at z.php and your local storage was created on a.php. If XSS is on z.php, I can scrub the entire your local storage as such. So say for example, oops. This is an application where a local storage or HTML5 component or local storage is used, for example. So we go to the login page over here. And this is again a Chrome plugin for developers, which will show us where the local storage has been used or so on. So we pass on this information, and as soon as we log in, as you can see, the application has created a local storage here with some kind of a hash value over here. And now this local storage is pretty much available across the domain. So local storage cat item hash. So this is how you can actually retrieve any local value or local storage which is used. You can actually enumerate the local storage as well if you want. If you don't know this name hash, you can do a 1, 2, 3 and whatever variables you want to harvest, you can actually harvest from a JavaScript. Now it has a persistent cross-site scripting, for example, over here. So we put it there, and now whoever visits that particular page, we are scrubbing their identities or local storage hashes over here. So say for example, if I go to the blog, this is my XSS, since I've got XSS. Now another user logs in and he visits the particular page, and his hash will get harvested. When you have a cross-site scripting and you are using local storage, it becomes a cocktail and possible to exploit. So we contributed something on a beef as such, and beef is also added nowadays. Beef is a framework for browser exploitation. So you can start a beef over here. It has a plugin for over here. Okay, so beef has started here. It has a plugin to extract local storage and a session storage, and this is your zombie or your console running on the beef. And this is a beef console where you can see HTML5 related stuff, local storage and a session storage. And as soon as someone get cross-site scripted, we can actually run a command over here. We say, okay, grab all the local storage from the browser. So it'll actually run the command, and it's waiting for command to get executed over here, and we harvested a local storage over here. So for example, value hello world has been stored and so on. Similarly, you can extract a session storage as well. Again, you can use the trick of either a runtime analysis or a static code analysis to figure out whether this particular application is using local storage or not. Another vector is SQL injection. So Web SQL is a part of HTML5. It provides SQL database and allows one-time data loading as such. So you have open database and execute SQL, and when this database created in the browser, it allows you to do offline browsing as well. So pretty much it will create the whole SQL client, server-side SQL will get replicated on the client side, and then you can execute pretty much select and whatever queries you want to execute. So over here, for example, we load the page and you can see there is a database over here, and then pretty much you can run a select query over here. So you can have this particular data get loaded, and this is your actual calls here. You're running a query. Now you can do a client-side SQL injection. Say for example, you have this variable 1 which is going through the DOM. So instead of a 1, if you do or 1 equal to 1, for example, you get the whole data back on the browser. So if you have XSS and your banking is using for example, WebSQL, then pretty much you can go ahead and grab all the data from the browser. DOM is essentially, as I said, is now DOM 3, which allows you to do XPath and a lot of different stuff which is already added on our document object model. And one of the injection is a DOM-based injections, DOM-based XSS injection script in the DOM. Several different ways: polluting eval stream, document.xss, so your document.write calls, your document.inner HTML calls, and so on. So all these different calls will allow you to do a DOM-based XSS. JSON-based XSS is possible. And one of the interesting thing is a third-party abuse, because you have this third-party stream which is actually coming into the browser, which allows you to perform DOM-based XSS as such. So one of the interesting area for DOM-based application is a mashup application. Say, for example, this is a mashup application of 2 or 3 different applications running on this one domain. So you want to see someone's profile here. So you go ahead and say show profile of this guy. Now this particular stream is actually coming from third party and in some kind of XML format, and then it get parsed, chopped, and get loaded in your browser through document.write or eval call. Now the John has posted something different in his first name or last name. He has posted a JavaScript. So that script will actually come to your domain. Your domain will supply a raw script back to you, and then you actually execute in your browser. So again, these DOM-based accesses are very easy to find when you do a static code analysis or when you do a runtime analysis of your JavaScripts. Another interesting area is a DOM-based injection and stealing. DOM is usually one-time loading. A lot of information residing on the DOM. So one of the interesting thing is when you are doing a DOM-based application at the slash page, the entire DOM will get loaded, and whatever variables which are global are available across the application. So these global variables, and you are not going to change your DOM. When you go from one page to another, your DOM will remain same, just the part of a DOM is going to get changed. So sometimes it's due to a poor programming practice or the way application is written, it opens up a batch of global variables. You just look at Google or look at any 2.0 application and look at how many global variables which are created in your browser. All these global variables are nothing but the local storage. So pretty much if you have XSS, then I can harvest, or someone can actually harvest all the global variables from your browser. So say for example over here, we have a page over here. So this is how actually over here we are doing a cross-site scripting via direct JSON parameter. And if a global variable is on it, we can say, okay, get that particular variable back, and you can actually go ahead and see the value of the global variable. So it's possible to do a DOM injection and stealing of information using DOM-based cross-site scripting. Another area which is abusing network calls. So HTML5 provides WebSocket and a XHR level 2 call. It allows you to make a cross-domain calls via raw socket. A lot of malware and worms can actually go ahead and leverage this particular technology. So with a WebSocket, pretty much you can do a internal port scanning if you want. So you can actually go ahead and do the whole internal port scanning using WebSockets. XHR level 2 calls are now implemented in all the browsers. So it's essentially what this particular call is doing is when it makes a cross-browser call, it will pass on another HTTP header, which is called the origin header. And the origin header, along with some of the access calls, will process your call or will reject your call. But one of the potential abuse over here is it allows you to do a one-way channel, because anyway that particular call is going to go on a wire to a cross domain, and then the domain will decide whether I want to send the content back to the server browser or not. And some of the browser will actually take the content but will not load into the DOM. So that's how the whole mechanism of this XHR level 2 has been implemented. Again, it's a great, because XHR level 2 is not going to replay your cookie. So it will not replay your cookie when you make the XHR level 2 call. So whole new policy has been created. You can find it on the WTE.org, which is called cross origin request sharing policy. So this policy actually dictates which call to be entertained and which call not to be entertained, and the new generation of tags or HTTP headers are added, which is origin or access and so on. And then you have always a traditional way of abusing your XHRs, your calls. So essentially what you are doing over here is you have your trading application, and when your trading application, you go to the trading application, you get authenticated, and then you end up on the attacker side, for example, and attacker side will actually pass on you a CSRF page, which force you to do a cross-domain call over here. So over here, for example, we are passing CSRF in the post, and we are adding a hidden tag over here, and we are saying, okay, pass on this JSON. So what we are doing is we are doing a CSRF with post and a JSON over here. So actually on the wire, you will have something like this created. You have a nice little JSON going with equal to foo at the end. But most of these libraries are actually looking for the good JSON. So it will look for the start of the good JSON, and as soon as the JSON ends, it will start processing. It will not look at this final stuff over here. Or this is over here, we have a content type, which is a text plain. It's not JSON. But even though all these different libraries are actually jolly well execute this particular HTTP request. So you get the HTTP response back, and then you can process. Similarly, it's possible to do a CSRF with AMF traffic as well. So all the traffic, as you can see over here, is AMF. And when this particular thing will go on wire, it will make the nice AMF envelope and will actually go ahead and hit to the server. And then some of the clickjacking possibility with HTML5 layering. So HTML has canvas and layer and so on, which allows you to do a clickjacking, where in a clickjacking, as a user, you will assume you are firing this particular event, but at the back end, completely some other event will get executed as such. So for example, very quickly over here, you have little, say, claim iPod over here, and you have this page over here. Now, just for the sake of clarity, I'm just putting this button is not required as such. So over here, when you click this particular button, so you have this layered created. So at the back end, there is an iframe, and in the iframe, you have loaded completely different page, which is called Google page, and Google's I am feeling lucky button has been mapped to your iPod button. So when you click the iPod button, actually you are clicking the I am feeling lucky button. This is again a kind of a click jacking, which we are doing, like we have seen a flash jacking and a Silverlight jacking. It's a click jacking where we are leveraging some of these HTML5 features and the frames and so on. So there is a countermeasures for it of the frame busting code which you can put, which will not allow you to load your page into any other's frame as such. So these are all about attacks, and you can do a reverse engineering to identify HTML5 based components. You can do reverse engineering to find Flash based components and Silverlight and so on. And pretty much we are putting some new tools out there, XAP scan for Silverlight analysis. You have app code trace for Silverlight analysis, HTML5 scanner for HTML5 analysis, DOM scan and DOM tracer is already out there, and so on. From the defending side, security at code level, so at JS, Flash, XAP should not have a server-side logic. So don't put your business logic there, don't put your data access logic there. Understand them as a very simple presentation layer only. Obfuscation may help a little bit, not much. Source code and object code analysis during black box testing is required if your application is using Flash and a JSON and a Silverlight extensively. Resource discovery and fuzzing must for SOAP, JSON, and AMF to identify backend issues. Careful with HTML5 implementation, particularly WebSQL and storage. DOM-based analysis and scanning is required, how your developers are putting your DOM-based calls whether they are using deval or they are using JSON parse and so on. Don't eval it, like use a parsing over evaling. So you can do that. Cross-stream analysis with a third party. So what is coming from a third party is very important. So one, definitely you can put a defense at your code level, and another is a short-term measures. If you're taking, then you can put a defense at a filtering level where you can put a firewall. But one of the interesting thing with the 2.0 application is that you need a incoming defense as well. So say for example, you are taking information, your application is taking information from a CNN and then tunneling that information to your client. So at that proxy level, you have to do a outgoing filtering where you don't allow a script tag to go from a CNN to your end client and so on. And then definitely a server-side stream which needs support for AMF, which needs support for JSON and so on. That is always required on the server side. Yeah, that's pretty much it. Let me know if you have any questions. Thank you very much for listening to it.